Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we are working on the August 2016 New York Algebra 1 Common Core Regents Problem 6. Sorry, this is the extra. There we go. If you want to access these exams, whether you're from New York or anywhere else in the world, it doesn't matter where you are, go to nysedregents.org, click on the appropriate tab, and all the past regents are freely available there. Here's the problem. The table below shows 6 students' overall averages and their averages in their math class. If a linear model is applied to these data, which statement best describes the correlation coefficient? Okay, so to do this, you should know kind of what the correlation coefficient means. Okay, so the choice 1, it's close to -1. Choice 2, it's close to 1. Choice 3, it's close to 0. Choice 4, it's close to 0.5. I'm just going to take a big guess, and I'm going to say it's close to 1. Okay. Anytime, just based on the scenario, I didn't even look at the data. Overall student average and math class average. Of course, I'm going to look at the data, but think about the scenario. Students with higher total averages usually have higher math averages, and vice versa. Students who have higher math averages also have higher overall averages. It's not true for everybody. I'm just saying on average, right? Now I look at the data, 92, 91. Both in the low 90s, 98, 95 in the mid and high 90s, 3 points away from each other, 84, 85 in the mid 80s, 80, 85 the low to mid 80s, both 75, mid 70, and 82 and 78 right hovering around 80. So all the numbers are very close to each other. So these make up a line, if you graph the points, that has a positive slope. Okay, the correlation coefficient, data that's close to each other, that's well correlated, is going to have a correlation coefficient close to -1 or to 1. If it has the sign of the correlation coefficient is the sign of the slope. Since the data has a positive slope, it has a positive correlation coefficient. So the answer is in fact going to be close to 1. It's not going to be close to -1 because the slope is positive. They're both they're both large at the same time. They're both small at the same time. That's a positive slope. Close to 0 would mean that the data is not well correlated at all. Close to 0.5 means the data is maybe slightly correlated, but not quite very correlated in general. 0 means not correlated at all. This is partially correlated. Okay, so here's another problem where we're actually going to ask you to get the actual correlation coefficient and all that stuff. So at this point, if you should pause the video, try the problem on your own, and when you're finished, press play to see our solution. By the way we're able to provide these videos, tutorials for free, is by having viewers like you see the video. So if you know anyone who would like who would be helped with the videos, make sure to let them know. Click the like button, subscribe, let your school friends know that we're here. We're providing tutorials in algebra, geometry, algebra 2, trigonometry, biochem, physics, and probably more to come. So here's the problem. The table below shows 8 students' overall averages and their average in their math classes. Overall student average right here, I see they vary from the low 70s to the high 90s, and the math class average, similar to the last problem. So if a linear model is applied to this data, what are the linear model and correlation coefficients rounded to the nearest thousandth? Okay, so we need to actually know how to do this. That's actually the reason why I created this problem, because it's not unreasonable for them to actually expect you to be able to put this in your calculator. So I click the stat button. The edit button is the first one, and I enter the data. 95, enter. 85, enter. 88, enter. 72, enter. 87, enter. 85, enter. 94, enter, and 98, enter. Okay, and the associated grades, see, notice that I'm going to put them in this list and they're lined up just like this. 92, just because this list goes sideways and the calculator list goes vertically doesn't matter, it's the same association. 88, and the ordering does matter. 89, because no matter what the ordering, 88 has to go next to 89, 72 has to be next to 79 in that order, so that's what we should be doing. 85, 85, enter, 99, enter, 97. Okay, cool, and that's the list, and I see that I have the same number of numbers, so I see that there's an error here. Okay, 85, 85, enter. I should have gotten a crazy answer if that wasn't there. So now to do the linear regression, I do calc, two variable statistics. No, I'm sorry, not two variable statistics. Linear regression, ax plus b, means that it's going to give me a line of the form ax plus b, where x is the overall student average and y would be the math class average. Okay, so I press enter. X list is L1, Y list is L2. There is no frequency list. I could store the equation as one of the Y functions just to show you how to do it. Y vars functions. This is not required for this problem, but there we go. So it's going to store the function on Y1 automatically. Okay, calculate. Okay, and I see that A is 0.739 and B is 24.206. So 0.739 for A and 24.2065 is just 207. That leaves me one of these answers. Okay, and I know that these are now wrong. Okay, now what about this correlation coefficient? Notice that it's missing here. This is one of the things that you have to get your calculator setting. Over here, the only way I know how to turn it on is the catalog. Right above the 0 is the word catalog. It's actually, I'm colorblind. I don't know if it's why it's hard for me to see. Oops, clear. Catalog, and you can scroll, or you can actually do press a letter. Let's see. Sorry, I really am colorblind in real life. So I can't see the letter D. So you're gonna have to be patient while I scroll. But if you press the letter D, it'll go straight to the D words, and we're gonna go to diagnostic on. Here's the thing. Diagnostic on. Press enter. Done. So that's why R wasn't available. Now it's going to give me the R values. Okay. So linear regression AX plus B. Sorry, let's try it again. Calc, linear regression AX plus B, L1, L2, frequency list. Store the equation. I'm just going to store it again into Y1 just in case I want it. Enter. Calculate, and I see that R is equal to 0.9069, which rounds to 907. Okay, so that is the answer. And now where does this come from? 0.823. Well, that's the value of R squared. That's something unrelated to any discussions that you normally do in Algebra 1. What we care about is the correlation coefficient is R, which is not 0.907. Okay, that's it. Thanks for watching. Stay tuned for the next video starting right now.